guys, today I'm going to give a presentation on my project, Space System Engineering, and this is my final report. I'm Evelyn Liu. System engineering is an interdisciplinary approach to research. It is not dedicated to the best performance of a subsystem or component, but to the needs of the entire system. And tries to achieve an optimal solution. As a complex high-tech system engineering, aerospace engineering involves a variety of professional cutting-edge technologies with large capital investment and many people involved and high risks. So, system engineering has become the best way to solve these problems. And then let's do a brief analysis of some basic parts in system engineering design. I will talk about 5 parts, which are concept development, stage, and engineering development stage, and post-development stage. System engineering challenges, and finally the summary and lessons I learned from this program. First, let's talk about concept development stage. There are mainly 3 parts in this stage. They are needs analysis, concept exploration, and concept definition. Firstly, let's talk about needs analysis. There are 4 steps in this part. The first one is operational analysis. Two factors have contributed to the birth and development of the aerospace engineering system. The first is the need for people to understand the Earth from a broader perspective. And the second is development of science and technology, and makes the space missions that were previously impossible to achieve possible. And second, functional analysis. The functional analysis process clarifies the functional requirements of each part of the aerospace engineering system and defines functional models and decomposes the overall engineering system from top to down. After the integration of each subsystem, the overall function of the system performs better than the sum of functions of each part, which, like 1 plus 1, is bigger than 2. And thirdly, we will talk about feasibility definition. The two main tasks of feasibility analysis phase are to analyze the physical achievability of system functions and to consider the cost of the system implementation, usually by collecting the previous data and of similar function units and theoretical analysis and experimental data. Engineer can evaluate the feasibility and the cost of the system, but for situations that the methods take above unreliable, engineers can do simulated environment tests. To evaluate if conditions permit. Fourthly, we will talk about the last step in needs analysis, which is needs validation. The effectiveness analysis. Of the system is the last and most important step in the needs analysis process. In this stage, system engineers tries to establish a performance model. To evaluate the system, the evaluation process includes operational efficiency analysis, cost efficiency analysis, and so on. The standards for effectiveness measurement may vary from different system environments, but system engineers can select some of the basic characteristics of system effectiveness to develop measurement strategies. Then we will talk about the second part in the concept development stage, which is concept exploration. The main task of the concept exploration phase is to transform the operational oriented system view to engineering oriented system view. In this part, a clear, measurable base that can guide the construction of subsequent system physical is formed. And when the system has updated optimization requirements, the original system baseline should be taken as the starting point. The third part in concept development stage is concept definition. The goal of the system definition phase is to select particular configurations. Among the various system concept alternatives to determine the baseline for subsequent system development and construction, trade-off studies, and the risk assessment are the two main tasks at this stage. After the concept development stage, let's have a look at the engineering development stage in aerospace engineering. Engineering development stage includes 3 steps. The first step is advanced development. The main task of the advanced development phase is to resolve the risk problems. In the system development process and verify the system design method and ensure that all components and subsystems can be used for the development of full-scale systems. The result of this phase is a detailed description of the system design and a validated system development model. And the second step is engineering design. The main purpose of this phase is to complete a more detailed and specific system design. This will be a complete system design, including the design of each subsystem and operating system. It should have been prepared for the manufacturing, integration, and verification of the system in the later stages. The final product of this stage is a detailed production baseline. For actual production and an optimized system test plan. Thirdly and lastly, in the engineering development stage, we will talk about integration and evaluation. The purpose of this phase is to verify production, design, and detail. To check whether the design has achieved the desired goals, whether there are still some undetected risks, and where improvements are needed. To provide a base for the next level of development. After the engineering development stage is the post-development stage. There are two parts in this stage: production, operation, and support. First, let's talk about the production. The production phase is to materialize the system design. And system details completed in the engineering design phase to produce the exact same product so that it can realize the design function and can finally be transmitted to the user's hand. The basic requirements of this stage is that the produced system meets the previous design functions. And performance requirements. And is characterized by availability, achievability, safety, and so on. For the operation and support part, this part walks throughout the follow-up process after the system is completed. From initial installation to critical testing and component replacement during scheduled maintenance to repairments and to major updates to large and complex systems or needs operation and support systems. Fourthly, we will talk about challenges in system engineering from the perspective of engineering system design. Compatibility between subsystems and components. And optimize the system design under limited time. And the resources and trade-offs in the middle of the design process are all challenges. And from the perspective of aerospace engineering systems, the difficulty to simulate the system environment and difficulty to verify the technology used in the system and design of the treatment plan. For emergencies. Are all very challenging. Finally, I want to talk about the summary and the lessons I learned from this program. Due to the uniqueness and the periodicity of the aerospace project, the system engineering method has always been the traditional research and management method in the aerospace field. At China and abroad. Before this class, I know nothing about system engineering nor aerospace engineering, but now I deeply understand the system and the important role of engineering methods in scientific design and the manufacturing process. system decomposition and integration are the core of system engineering. And system engineering is an indispensable of realization for the aerospace industry. And that is my presentation of my program, and thanks for watching. Bye.